folks, welcome to Legacy IAS Academy. In this video, we will be discussing a current affair topic presented to you by a faculty, Sushma KP. So what is the topic that we will be looking into? NISAR satellite. Why is the NASA-ISRO Earth mission so important? Understanding? So this is the topic. We will be discussing as to what is NISAR, what is SAR technology, what are the key applications of these. We will also see how is India-US collaboration on this. We will see how NISAR is a game changer. We will also see the implications for India, what are the challenges ahead, and also a possible mains question. Now I've told you the topic on what micro topics we will be discussing. How is it relevant to your UPSC? Look at this, it is important from your GS paper 3 perspective with respect to science and technology, understanding in the developments, their application, and GS paper 2 with respect to your Indo-US cooperation. Alright. First and foremost, what is this NISAR satellite? If you have to know, it will be, when it will be deployed, it will be one of the world's most powerful Earth observation satellite. So the keyword you have to know about your NISAR is it is an Earth observation satellite. One of the major thing when we tell Earth observation satellite, the concept of Earth observation satellite is not new. But of this level, this is the first time. What do I mean by this level? Let's say whatever the climatic conditions, let it be. Here I will introduce two things, S-band, L-band. Let it be raining, let it be monsoons, let it be cloudy, let it be sunny, irrespective of any weather conditions, it will be able to give us accurate data. Understanding? So this kind pave, this is the first thing that, or the first satellite in the entire space station that we will be having. This is jointly produced by both India and USA with your India say ISRO and USA NASA. Thus the name NI. Understanding? SAR stands for synthetic aperture radar. So this Earth observation satellite will be very helpful for giving us accurate information on climate, agriculture, crops, their growth stage, maturity. Yes, even the growth stage, maturity, all of these data will be given to us, especially with respect to climate change and also your natural disasters. This will be a game changer. What is NISAR? Like I said, NASA-ISRO synthetic aperture radar. It is a joint Earth observation satellite. Okay. What are the highlights or what are the firsts that we see? This is unlike anything that we have ever had before. So when we tell it is unlike anything, what are its highlights? It's the world's first dual frequency SAR satellite, synthetic aperture radar satellite. It uses both L band as well as S band. That is why I said dual frequency. It is the costliest Earth observation satellite made of 1.25 billion, which is chipped in both by NASA as well as ISRO. ISRO chipped in around 90 million. Remaining is by your NASA. So, economically, it seems very, let's say, standpoint on economic perspective, it is good for these two to collaborate. And per day it generates 80 TB of data. Understanding? Now, what is this SAR technology? First and foremost, look at this. SAR, if you have to just understand one word, this advanced imaging radar, it works in a microwave spectrum. So it is almost like it will give out, okay, it will hit the, right, it will hit out the light. Whatever the image that it gets back from the object, it will take in and it will give the data. That data, that is what I mentioned as 80 TB data per day. Understanding? It penetrates through cloud, smoke. It also equally functional in the night time. Understanding? Now it has double SARs, that is we said dual use or your dual frequencies, that is your S band and L band. L band is provided by your NASA. This goes for deeper penetration with respect to your vegetation, ice, sand. S-band is provided by your ISRO. It is more of your surface level crops, canopies, water. Understanding? And if you see what are the specification that it can do with these things, because of this dual frequency integrate into one thing, it can provide us real time imagery. Understanding? And also it has a large antenna, which means 12-meter antenna, equivalent to ground pay. If you're going to take a picture, 20 kilometers can be covered. Understanding? It also has a gold mesh reflector. What are its key applications? If you see from your climate and environment monitoring perspective, it will be able to do the biomass estimation. Again, when I mentioned with respect to climate change, this will be a game changer, right? It will mention the glacier melting, polar ice cap sheets, and also with respect to the rainforest. Now we have seen the many records that your rainforests are reducing, so it will also showcase all that real time data. And also if you see with respect to agriculture and forestry, again like I mentioned, from your plant growth to maturity, all the data will be very much given, and this will be a game changer with respect to your agriculture and also with respect to your disaster management. Understanding? Crop mapping of your sugarcane, maize, soya bean, and this will also give us good amount of soil moisture, which means in this soil how can or how much can the yield be can also be predicted with this. Understanding? So this will give us a more updated data. Okay, we will have real time facts before we start actually even sowing the seeds. With respect to natural disasters, it will study the earthquake deformation, like I said, because of its usage of both S band and L band, right? Where one is very much deeper and one is for the surface, we will be able to even map through the surface, right? Landslides, volcano mapping, and also early warning systems with respect to your floods, drought. With respect to urban infrastructure, if we see, it will be more about helpful. We have started this urban mobility, green cities, smart cities. So for all of these data can be useful. Now the thing we can see is this will more of reduce the impact that is caused by your natural as well as man-made disasters. Understanding? How was the NISAR coming into picture, or what was the beginning stage? First and foremost, this idea was conceptualized in 2007 and NASA started its research and development in 2008. Your India say ISRO joined because India also had the same objectives of developing something. They said if it will be better if we collaborate with respect to the economic perspective and also technological integration. So ISRO joins in 2012 and formal agreement was signed in 2014. It will be deployed and launched by ISRO in 2024-25. So if you see what are the things that your NASA and ISRO are giving. Your NASA is giving your bands, L band, radar, antennas, GPS. With respect to ISRO, it is giving S band. It is giving the launch satellite bus. Understanding? So both of them will have ground stations in the joint operation. Alright. What are the strategic dimensions? First and foremost, data sharing for climate diplomacy. Second thing is it aligns with Artemis Accords and Quadtech. Artemis Accords means it is trying to again relaunch humans on moon. Recently, Shubhman Shukla also went to your International Space Station. That is one of our first. And also this will be a huge trust in your technological exchange. Why is NISAR a game changer? Like on all the time, this is the first time we are using real-time data which we will be generating from your two frequency or dual frequency. 12 days revisit cycle, as in it will give us the highest resolution images, and also it will give us both the surface as well as beneath ka data. And this is considered as one of the engineering marvels with regarding to your both dual energy radars. What are the implications to India? First of all, it will boost your ISRO satellite profile, and also this will enhance space diplomacy through data sharing, And lastly, this can be integrated with all our other existing missions with respect to OceanSat, Cartosat, okay, other mapping understanding. What is the domestic use of this for India? First and foremost, agriculture. We have Pradhan Mantri Fasal Bima Yojana, which is like a crop insurance, so we can have a definitive data even before we sow our seeds. We will also be having a good amount of forest carbon stock, or let's say we have something called as nationally determined targets. We will be able to meet that. We will be able to align with our SDGs and also keep in line with our Paris conference. And this will also give us infrastructural safety. That is where we brought in your urban mobility, urban smart city planning, understanding. So this will give us a self-reliant technology can be built through this. What are the challenges? First and foremost, the challenge comes with respect to 80 TB per day data handling becomes very humongous. Understanding synchronization of operations between two of them, and also dependence on international supply chain, because we do not yet have the capacity to deal with such large amount of data. So what can be the way forward? India to develop more indigenous SARs, synthetic aperture radars, and have bilateral relation with other Quad nations with regarding to space technology, and also Earth monitoring satellite space. We have to bring in more and more of integration with the mapping portions. Understanding? So, in the end, what is NISAR? It is a synergy of both India and USA, that is ISRO and NASA. It uses dual band SAR, that is your L band, S band, and this will be very excellent for one satellite global impact with regarding to your climate, food, disaster management, etc. Now, if we see a possible mains question from this topic, evaluate the significance of Indo-US collaboration in space through the lens of your NISAR mission. So you will mention all the specifications, why is it is, let's say, the first time ever, how it will be a boost for India and India's domestic use. Understanding? So that is how you have to go about the question. With this, we have come to the end of the content. If you like our content, subscribe to our channel, hit the like button, share it along with your friends. Thank you.